Hello everybody, Root Beer here again for another contest video. We're going to be continuing our look at the 2011 Friar Contest. Okay, we just did question number 1 in the last video, so if that's what you're looking for, you can go back and take a look at it. We're on to question number 2. So let's take a look at that together now. Alright, question 2. In any isosceles triangle, ABC, with AB equal to AC, the altitude AD bisects the base BC, so that BD equals DC. Okay. So this is just sort of a basic isosceles triangle fact that we can use, apparently. Alright, A, we've got two things to do here. As shown in triangle ABC, AB equals AC equals 25, and BC equals 14. Determine the length of the altitude AD. Determine the area of ABC. Okay, so once we have the altitude, we have the base. We'll use 1/2 base times height, and we'll figure out the area of ABC. Okay. So let's jump straight into A part. We'll redraw our picture a little bit. (25, 25). Our altitude D splits things in half. So in total, this is 14. A, B, C. But each of these is going to be 7. Okay. Well, I notice the triangle ADC is right angled. So that means, by Pythagoras' theorem, AC squared is DC squared plus AD squared. So why are we setting it up like this? Well, we want AD, we want the altitude. So 25 squared, let's write the 5 a little better. I think at this point I'm kind of known for drawing a 5 that almost looks like a 3. 25 squared, 7 squared, we just figured that out, plus AD squared. Okay. Now some of you might be familiar with this. It's going to be a 7, 24, 25 right angle triangle. And some of you may not be familiar, but we can already predict AD is going to be 24. This is a common triangle that comes up a lot. So 25 squared, so 625 minus 7 squared, that's 49, is AD squared. Well, 625 minus 49, that's going to be exactly 576. So AD is the square root of 576, which, wouldn't you know it, is 24. Altitude is 24. As I said, area is 1/2 base times height. So 1/2 14 times 24. And we can work that out. 14 times 24, that's going to be 336. Divide that by 2. We get 168, which is the number of hours in a week. Just a little bit of a number association there. Eventually you just notice numbers. You just know things about numbers. So 168, number of hours in a week. That's irrelevant to the question. Just a little fun fact for you. Okay. So we have the altitude, which is what we want, and we have the area, which is what we want. We could probably put a little box around the area. And that concludes A part. We have both the things we were asked for. Okay. So B part. Triangle ABC from part A is cut along its altitude from A to D. So here it's been cut. Each of the two new triangles is then rotated 90 degrees about the point D until B meets C directly below D. So here they're coming together. We're just sort of pivoting both triangles with D fixed. And that's figure 2. This process creates the new triangle, which is labeled PQR. So B and C come together to form a single point Q, and A was split into 2 points P and R. Okay. So the nice thing is we're rotated about 90 degrees, and BC will meet directly below D, so this is still going to be a 90-degree angle right here. Okay. And so we have 2 things to do. In PQR, determine the length of the base PR, and determine the area PQR. Okay. Now, there's not a whole lot of mathematical logic we can use. We just have to sort of refer to the figures and the method we use to obtain this triangle. So PD and DR are both going to be the same as AD, which was 24. We figured that out in the last part. So if we want PR, which the question asked for, we just need to add these together. 24 plus 24, that's 48. Okay. And I believe we're also asked to determine the area of PQR. Now there's 2 ways I can think of immediately to go about this. I mean, all we did was cut this triangle and rearrange its pieces, so the area hasn't changed. The area hasn't changed at all. We've just sort of rearranged the area. And so we could probably make an argument that way. Or we could make the argument that DQ is the exact same length as BD and DC. So this is going to have an altitude of 7. Right? We figured out BD and DC in the last part. We figured out that that was 7. So we could do either way. It really doesn't matter. So these guys are all going to be equal. They're going to be 7. Now, since we rotated our triangles, by 90 degrees we can see that QD is an altitude of PQR. Area is 1/2 base times height. So that's going to be 1/2 of PR times QD. And that's going to be 1/2 of 48 times 7. Well, what's 48 times 7? Should be 336, just as it was last time. So 336, 1/2 of 336, that's going to be 168 once again. Okay. Like I said, you can do it this calculation way, or you could argue that we haven't gotten rid of or added any area, we just sort of rearranged it to make our new triangle. I think that's a perfectly valid way of doing it. Okay, so that's B part. We got those two sub-questions done. Now C. There are two different isosceles triangles whose side lengths are integers and whose areas are 120. One of these two triangles is XYZ as shown. Determine the length of the three sides of the second triangle. Okay. So, we want side lengths integers, and we want area of 120. This is one of them. And we can't help but notice the similarity of XYZ to PQR right here. And if it's a C part, we're likely going to be using some piece of information or some technique we learned or developed ourselves in A and B. So let's think. If we got a triangle that looks like PQR, and as we remarked, this process does not change area, just rearranges it, I bet if we undid this process, if we reversed it, so if we cut along here and folded X and Z up to meet up here, we'd get the same area, and we'd have another isosceles triangle. It would still have 17 and 17 as its sides, and we'll likely get integer lengths for the sides, and the area will still be 120. So we see a 17 there. That could immediately tell us that we're looking at a 17, 15, 8 right angle triangle. That's another common triangle that you might want to get used to if you're trying to do these contests in real life. So we'd get another triangle with the exact same area, which is 120, and that's exactly what we want. Okay? But this process here, it creates a new triangle, and it's going to have the same area. We either can remark that by realizing that we had the same area here as we did here. That's perfectly valid. Or we can just remark, as I have, that this process doesn't change area, just rearranges it. I think that's about the 34th time I've said that now. Now, this triangle XYZ isn't exactly oriented so that we can apply the process, so we're going to flip it, but that doesn't really change anything. Oh, sorry, the Y is at the top, isn't it? That's X and that's Z. So each of these little guys is going to be 15, and this is going to be 30. Alright, so once we have the intersection of x, z, and our altitude from y, we know, because this is an isosceles triangle, that it splits x, z in half. So that 30 becomes these two 15s. Well, then we can use Pythagoras again, and we get that yw squared is going to be yx squared minus xw squared. That's 17 squared minus 15 squared. That's 289 minus 225, which is 65. So yw is equal to 8. This isn't the best picture. So we're cutting. We're doing our process. And we need new labels here. So I don't know. Let's go with FGH because we're doing the fryer. So we have area of 120. FG is equal to GH, which is 17. Actually, a better way to write that, I guess, would be FG and GH are the same as XY and YZ, which is 17. FW and WH are equal to WY, which we just figured out was 8. That means FH, this length here, is 16. Since both of these side lengths are 17, we get an isosceles triangle. And its side lengths are integers, as desired. Okay? We have an area of 120. We know it's isosceles, and its side lengths are integers. That's exactly what we were asked to do. And we can see that it is a distinct triangle from our previous one, our x, y, and z that we were given. Most notably, that had a base of 30, whereas this has a base of 16. Okay. And the height here is going to be 15, but that's irrelevant. If we didn't want to argue that our process preserves area, which we didn't really have to, we could have used the process, and now we know that the height's going to be 15, the base is 16, 15 times 16 over 2 is still 120. Okay? But either way, we have found the isosceles triangle we were asked for, and we were asked to determine the lengths of the three sides of this second triangle. Okay, so 17, 17, and 16, we have those written in our solution. And that concludes C part, and there isn't a D part, there's just question number 3. So hopefully you guys will join me for question number 3 on the 2011 Fryer. And yeah, I'll see you guys then.